Welcome to Lab 4, Week 4. Today we're going to be going over simplifying radical expressions to start. So, very simply, what is a radical expression? Well, if we have learned in the past, a radical expression is a fancy way of saying square root. When we do simplifying of radical expressions, it's really important that we know the factors that make up our numbers. It'll make it a lot faster for us. So for part 1a, we look at the square root of 81. Well, if I know my math factors, I know that the square root of 81 is 9. Square root of 225, again, I can plug it into my calculator and I know that it'll give me a nice, pretty 15. Looking at C, I have a negative in the front, so no matter what, my answer is going to be negative. And the square root of 49 is negative 7. Again, for D, I look and notice that I have a plus or minus, so I know my answer, no matter what, is going to have a plus or minus in it, and the square root of 144 is 12. E, I plug it into my calculator and I realize I get a decimal. Well, this is when we're going to go about simplifying radical expressions. So I know whenever I do these, I'm looking to, my rule of thumb that I have taught my students in the past is I'm looking for numbers that start with a 4 and a 9, because I know that these are the two smallest numbers that I can take the square root of. So if I look at 8, I know that 8 can be broken down into 4 times 2. So I know that I can take the square root of 4, which is 2, and that remaining 2 just stays underneath my radical. Again, I plug square root of 32 into my calculator, I get a decimal, so I know I'm going to have to reduce it. And again, I'm looking for the smallest thing that I can reduce it to. So I know the square root of 32 is the same as saying 4 times 8. Well, if I notice from my previous problem, I know I'm going to also have to break down that 8. So I'm going to say that that is 4 times 4 times 2. And if you've ever done these in the past, you know that if you've got two 4s there, you're going to just pull one of them out front, because that's the same as saying 16, and the square root of 16 is 4, with our 2 remaining underneath. Again, looking at square root of 24, I'm going to break it down into two numbers that I'd recognize. So I know that the square root of 24 is the same as saying 4 times 6, right? So then I have to take a look at the 6 also, just to double check, and I know that it's comprised of 2 times 3. I know I cannot take the square root of 2 or the square root of 3, so the 6 is going to remain, while the square root of 4 is 2, 6 remains underneath. Square root of 48, plug it in my calculator, I get a decimal, so I'm going to reduce. I know that it reduces to be 4 times 12. I know I'm also going to have to break apart that 12. I know that he breaks apart into 4 times 3. So again, 4 times 4 is 16, and the square root of 16 is 4. So my answer is 4 with a 3 remaining. Square root of 71. Plug it in my calculator, get a decimal, so I'm going to start trying to break it apart. First, I'm going to see, is 71 divisible by 4? It's not. Is square root of 71 divisible by 9? It's not. So I know I cannot break down the square root of 71. So my answer remains the square root of 71. The reason why I use those numbers is because it's a really, really quick way to figure out if anything is divisible by it. All right, so J, 250. Well, I notice that it has a 0 on the end, so I know I'm going to be multiplying it by a 10. So it can be broken down into the square root of 25 times 10. I can take the square root of 25, which gives me 5, and I look at that 10 and I go, okay, 10 is made up of 2 and 5, and neither one of those are you can take the square root of, so, oh, not 5, I apologize. That 10 remains underneath our square root. All right, K, 500. I know that I can take the square root of 100, so I know that 500 is the same as saying 100 times 5. Square root of 100 is 10. That 5 remains underneath the square root. Again, I'm always looking for numbers that I know I can take the square root of. Okay, so 125. Well, I know that this is the same as 25 5 times. So again, I take the square root of 25, which gives me 5. And that 5 remaining stays underneath my square root. Now we're going to move on to solving equations. Okay, a good rule of thumb whenever you're solving equations, you're actually going to take the PEMDAS that you're used to for using expressions, for solving expressions, and you're actually going to apply it in reverse. So you're usually going to go addition and subtraction first, multiplication, division second, exponents, parentheses last. Okay, but as you go along and get used to this, you'll realize that you can actually kind of manipulate it a little bit and do different orders. When to know if you're going to use PEMDAS or if you're going to solve equations, you will use the reverse anytime you see an equal sign. Okay, expressions you will solve, just work them until you can't work them any further when there is absolutely no equal sign. Okay, so looking at the very first one, I have x equals 7y plus 5. Well, I'm looking at getting to this y. So the first thing I'm going to do is I'm going to do my addition or subtraction. Well, I have to do minus 5 to move the 5 to the other side. So I get x minus 5 equals 7y. And of course, divide both sides by 7. Whatever you do to one side, you must do to the entire other side. So I know my answer is x minus 5 over 7 equals y. You can also take this, I like to write mine as y equals. So I get y equals x minus 5 over 7. These are the same thing, they're just flipped. All right, B. I look at my problem. I have multiplication, I have an exponent, and I have addition. So I'm going to do my addition first. So instead of plus 8, I'm going to subtract 8 to move it to the other side. So I get x minus 8 is equal to 4y cubed. Remember, if I'm going in reverse, then I'm going to look for multiplication division. So I'm going to get rid of the multiplication by division. Again, whatever I do to one side, I do to the entire other side. So that I get x minus 8 over 4 is equal to y cubed. Now, how do I get rid of a cube? I know I'm going to cube root it. And whatever I do to the other side, I have to do to the entire other side. So I take the cube root of the entire other side. So these are gone, and I get y equals the cube root of x minus 8 all over 4. Now I cannot take the cube root of 4, so I cannot reduce this any further. He is going to stay exactly the way that he is. And we're going to move on to the next one. Now, when I teach solving fractions like this, typically teachers will teach you to multiply by the denominator on both sides. But my students tend to make a very big mistake on this second side because they forget to distribute the x on both sides. So I like to teach a different method. When solving fractions, if you notice that what you're solving for is in the denominator, okay, this is the only time that this applies. When your y is in the denominator, or what you're solving for is in the denominator, all you're going to do is put the other side over 1 to make it into a fraction, and you're going to flip both sides. So this becomes, instead of an x, it becomes a 1 over x. And this becomes y minus 2 over 5. So I flipped both sides. So now what I'm solving for is in the numerator. And then I can quickly solve the problem. So I know I'm going to multiply both sides by 5 to move him to the other side. Remember, this is technically a 5 over 1, so this is going to be a 5 over x equal to a y minus 2. To solve, I'm going to add 2 to both sides. Remember, I cannot add that 2 to that fraction. So this becomes 5 over x plus 2 equals y. And that's it. He stays just like that. All right, D, nice and easy. I have a subtraction and I have an exponent. So I'm going to do subtraction first by getting rid of him, adding him to the other side. So I have x plus 3. Oops. Equals y cubed. And how do I get rid of a cubic? Well, by doing the cube root. So my answer becomes y equals, on this side, come on, cube root on this side, so that I get the cube root of x plus 3. He is reduced, he is simplified, I keep him the way he is. All right, question 3. We find 5 points on the graph when we have x plus 2. Well, I'm going to help you out because this graph is a little hard to read with the dots and stuff like that. So I'm going to show you how to do it on your calculator. So we move this around a little bit. All right, so we have our calculator. We're going to go into y equals in our calculator. And we're going to plug it in. We're going to go the square root of x. Oops, not 2. Sorry. X plus 2. And we're going to close out that square root. Very important that you close out with a parentheses. And then we're going to hit second. And instead of graph, we're going to hit table second. If you hit the yellow button, start reading the yellow words. All right, notice we have errors until we get all the way to the number that we're looking for. The first clean number that we see is going to be a negative 2, 0. Well, that happens to be right here. Sorry, that happens to be right here. So we plug in negative 2. What is going on with my pen? Sorry, guys. Negative 2. Odd. Okay, we plug in negative 2, 0. Go back to my graph, or my table, and I notice that my next clean point is at negative 1, 1. So I'm going to put that negative 1, 1, which of course I know is right here. And again, go back to, I'm going to look for my next clean point. I have it at 2, 2. So again, I put 2, 2. I'm going to plot it also. Look for my next clean point, which is at 7, 3. So I go over 7, 3. And then I'm going to look for my next one, which happens to be at 14, 4. Now it says, what is the domain and range of this function? Well, my domain, if I remember correctly, my domain is only my x values. So I'm going to take, and I'm going to show you. So I go to my farthest point to the left, which happens to be here. Draw my little line. And I know that my graph goes on to positive infinity. So I know my graph starts on the x-axis at negative 2 and goes on to positive infinity. Now my range. Remember, I always read my range from the bottom to the top, okay? So I'm going to find my lowest point on my graph to the bottom. Well, it happens to be right here on my x-axis. So while this might be my x-axis, it's also known as 0, guys. You have to remember, it's also 0. Same for the y-axis. Your y-axis is also technically 0. So I know that it starts at 0, and of course, if I'm going and reading it up, it goes on to positive infinity. So when I go to write my range, because it starts at 0 and it is a point on my graph, I'm going to use my brackets, and it goes on to positive infinity. Now, for the next question, it wants you to actually take and flip or switch your x and y values in the coordinates and just write them down. So we have to switch that -2, 0 becomes 0. -2, -1, 1 becomes 1. -1, 2, 2, well, even if you switched it, it's the same. 7, 3 becomes 3, 7. And 14, 4 becomes 4, 14. Now, it wants you to take those points, and it wants you to plot them now. So we have our first point, let's say 0, -2. So at 0, down 2, we have a point. Let me zoom in for you guys. And then we have a point at -1. Oops, sorry, 1, -1. Our next point is at 2, 2. Next point is at 7, 3. Oh, as I'm just, I'm looking at the wrong one. Sorry, guys. 3, 7. And our next one should be at 4, 14, which I believe ends up taking us slightly off the page. And I'm going to take, and it's not a complete graph until you draw your lines. And remember, when we are drawing our graphs, we put an arrow at the end. It does not stop. It's very important. When we are drawing them, it does not stop. It keeps going on to infinity. Now it wants us to take, and it wants us to do the same thing that we did for the other problem. We're going to write our domain and our range. Again, I'm going to put my domain, I'll put my domain in red. I'll do my range in green. So red, my range. So remember, farthest point to the left happens to be right on my y-axis. Remember, that's also 0. So I know my domain is going to go from 0. Remember, my graph goes on to positive infinity. Now my range, farthest point to the bottom, I know, starts here at -2 on my y-axis. So range is -2. And it also goes up to positive infinity.